Yo, what's up, guys? Welcome back. I think today's episode 134. I think yesterday was 133. We did an EV. Today we got 134. Got a Vaporeon. Might be all the different EV types. I'm actually not feeling well right now. I don't know what's happening. I kind of had some food and I'm just like not really feeling great. Definitely been a long day today.
The deadliest warriors become the greatest.
Really no Yeah, so there's that sound. Yeah, I'm gonna do one problem today just because I don't know what it is. I ate and I'm not really feeling the best right now, so I'm just gonna do one problem and get our stuff done for the day. Actually, candies you can get from boxes. That looks like a good problem to do as well, but probably not gonna do that problem. I'm gonna do a problem that I haven't done today, because I like doing a different problem I haven't done. Don't always want to do the same problems. Maybe we can take a look at a graph theory problem. Graph theory, find town dredge, counts merge, course schedule, BFS. Man. Shortest path in binary matrix. What? Given n times n matrix, return the length of the shortest clear path in the matrix. There is no clear path, return -1. A clear path in binary matrix is a path from the top left cell of 0, 0 to the bottom right cell, such that all visited cells of the path is 0. All the adjacent cells of the path are a-directionally connected, i.e. they're different and they share an edge or corner. The length of a clear path is the number of visited cells of this path. So finding the shortest path with zeros. We can go diagonal as well, pretty much. So yeah, for at this thing here, we can either go 1, 2, 3, 4, 5, 6, 7, 6, 7, 8. We can go in 8 directions. They have to be a 0. So obviously we can tell this is classic BFS problem. I mean, it can be solved with DFS too, but I think it's pretty obvious that it is a BFS problem. That's a 49% acceptance rate. That's interesting. Okay, so I have to think here. The way I'd start this problem. From collections, import DQ. Right. Firstly, I'm going to make our rows. Rows is equal to grid 0. Equal to the length of grid. And our cols is equal to grid 0. Rows and columns just to make sure we did this correctly. Like to visualize stuff. Ow. I think we need the length here. Whoops. Man, I am not feeling good right now. Okay, so gotta think about how we're gonna do this, right? So obviously we start at 0, 0, and we're going to the bottom right cell, right? So really, all we have to do is create our queue and pretty much loop, right? Like go through each cell and just append, right? So, okay, so let's do Q is equal to DQ. We do Q.append. Let's append our 0, 0 as a tuple, right? And we can go while Q. Okay, we can row col is equal to Q.popleft. Right, obviously we're going to need a visited array, right? So visited is equal to set, right? let's add our visited is visited dot add. Let's put that here. So we got a visited set. We got rows and columns. We got while q, we got our row and our cols equal to q.pop left. We need a directions array. Okay, so directions is equal to this, right? Let's do up, down, right, left, right? So up would be 0, minus 1. Sorry, we need to make these tuples. 0, minus 1. Our down would be 0, 1. Our right would be increasing, 1, 0. And our left would be decreasing, minus 1, 0. To do our other diagonals, we would have to do, well, how would we look at this one, right? We would go 1, 1, right? So it would be 1 would be 1, 1. Then we know 1 could be the opposite, minus 1, which would be this one. And then to do this one, we have to go down. We would go down, which would be 1. And then this one would be, to go left, it would be minus 1. And then we do the opposite of that, which would be 1, minus 1. So I believe this should be correct. And then what we do here is we go, okay, well, for new row, new col, and directions, okay, we want to do new row is equal to nr plus row. New col is equal to nc plus col. And then we want to do if 0 is less than or equal to new row, but it's less than rows, check the bounds. 0 is less than or equal to new col, but it's less than cols. And new row, new col is not in visited. Okay. Okay, actually, wait, we want to check that. What is it? Grid. Yeah, grid. New row, new col is equal to 0, and it's not in visited. New row, new col, not in visited. Then we know that it's good, right? Then what do we want to do here? Well, we want to check took 1, 2, 3, 4 to get there, right? 4 being 1, 2, 3. So obviously what I forgot here is we need a count, right? Something that we're going to return. We can add our count. Now I think about it, our count is going to be global here, but we don't want that. We're going to be looking in so many different directions. So let's add a third tuple, right? We add 0 here, specifying the count that we're at, right? New col, and we got our count. Let's do our max count. Sorry, our min count. Min count is equal to, we want to set this to the infinity. So float inf. Okay, so then we would go through here and we would do, okay, well, We're at 0 right now. You find it, add 1 to it, right? So let's do visitor.add. We can just do 0, 0. We don't need, actually, we don't need the count for 0. So visitor.add. New row, new col. Okay. Then we can do q.append. New row, new col. And then obviously our count plus 1. If new row, if new row, new col is equal to rows minus 1, rows minus 1, cols minus 1. Then we want to do min count. Min count is equal to min count and count. Okay. I believe here we would just return our min count. We will add to our queue. If this is our current one, then we want to check that count. Is it guaranteed? Okay, return min count if min count does not equal float inf else minus 1. We got it in our while. Whoops, we want to take it out of our while. We got 2 here, but we got 2 here, 0 here. Why is that? Could our directions be wrong? Maybe it could be our directions are right. I feel like our logic seems pretty good. That is right. Our initial count should start at 1. I did not think about that. And BFS, that is true. It's guaranteed. We don't even need to check min count. I guess we don't need to check it here, right? we can simply just check it here as well. Then we would return count, right? And return -1 here. This needs to be row count call. Row call. I'll put 4 -1. If grid 0 is equal to 1, or grid rows -1 calls -1 equal to 1, we would return -1. I accepted, but I'm wondering why it can't get there. Oh, it's because our first one is 1. That's why. Interesting. Okay, there's our problem for the day. Appreciate you guys watching. I'm not feeling the best. I'm happy they went kind of quick. Appreciate you guys watching. I'll see you guys tomorrow.